Hello. Welcome back to part 5 in the SC30 logic board assembly stream. This is the reproduction board that is made available as open source hardware on GitHub, made by Bully. Very professionally made reproduction board. As I mentioned in the past, this is not an absolute 100 one-to-one replica, but it's a reverse engineering of that very board. So, and it's very easy to, it's part 5 already. Hey, Brendan. So we're making pretty solid progress. In the last stream, we got all the IC, surface mount ICs put on the board. They should be fairly good order. I've checked off the stream. I've gone around, checked for port joints or for breaches, and I think it should be in fairly good shape all in all, but there may be 1 or 2 or 5 or 10 pins that aren't perfectly attached, so we'll see. Now there's one thing I need to actually correct. I made a mistake in the last stream, and I attached what I think was a 220 microfarad, no, 220 ohm resistor pack on, let's see here, let's bring it up to the bottom again, on RP8, which actually expects a 1K ohm resistor pack, and I have that right here. I just didn't find it in my box of goodies before. So this is 1K ohm resistor pack 4816P-1-102LF. So we should rework this, get rid of this RP8 IC and put the right one on there. Let's double check again. It's RP8, right? Yes, RP8 needs to go. So this is where it's actually helpful to have used the solder paste, because this solder should melt very quickly if we just apply some heat. Let's bring this down to 350 degrees, maximum airflow. Let it heat up. It's heated up, and we shall apply some heat onto this chip until it decides to pop off. Or actually, did I use? I think I used the regular solder technique here with a regular solder. So yeah, it will not pop off as easy as with solder pastes, but it should still be fairly quick. There we go. Yeah, so easy, so easy. Pop right off. Let's get the soldering iron. Put this chip off to the side. It's still a very useful chip to have for future projects, but I don't need it right now. Here's the real deal. I always order extra. Let's put it back in its baggie. Put it to the side. I think we should start out by cleaning up these pads. Let's bring the thick wick for that. We can keep one of the pads. Gently suck up the solder. Looks all right. Let's wipe it down, get rid of the flux and crap. What is this? Oh, did the pad come off? No. That doesn't look good. What came off there? Did we lose something? Better keep an eye out what happened there, because I don't see any of these pads here being bad. Is this a leg that came off of this? Doesn't seem like it's... Oh, no, it's sorry. I should have looked at the chip that we took off. All the legs look intact. So why do we have something that looks like a pad floating around? That's not promising. Let's put it to the side here. Keep an eye out. Come on. There. Because I think all of these pads look good. Alright, so let's see if we can attach the new chip. And the little dot is right there. That should align with the silk screen markings, like so. Let's use the finger technique, avoid burning our fingers, but let's see if there's enough solder on that pad. Seems that there is. Maybe we need to angle it a little bit. There we go. Probably reflow this one. All right. Oops, we got a bridge there. Bridge is gone. So do the other side. Let's turn on my fan. Looks all right. Still a little bit worried. What on earth? Where on earth did this little pad come from? It looks like it came off of something for sure. That is so worrying. It was literally as we slid this chip off. Maybe we can see if this little where'd it go? Where did the little pad go? Oh, it's over there. Okay. Can we melt it? No, it's definitely a pad. Definitely a pad. Yeah, it could have been a pad that came off of the donor board for sure. That was kind of a. So here it is. It's the donor board. So yeah, lots of crappy pads on here for sure. That could have come along. Anyway, for now we're back in business and ready to tackle other components. So one thing that we need to do, and actually I need the hot air for a moment again. We need to actually bring the donor board back for a moment. Let's put that over here. Because we need transistors. So we have two transistors here, Q1, Q2, and one down here, Q3. And in hindsight, I should probably have got new ones, because these are a little bit iffy when it comes to capacity. Well, these ones are pretty good. The transistor down here has seen a little bit of cap juice corrosion, but hopefully it will be good enough to use. We can do a quick test in a moment, but let's just apply some hot air and get these off. Bring it down to 350 degrees again. Let's see if just applying the hot air will melt these. Should just take a moment, hopefully. I'm holding the hot air gun maybe an inch above the board there. Okay, one came off. Two came off. So far so good. Let's put them over here. Head over here. Oh, hot board. Other side. There's Q3. There's some hot air. So this is the corroded one. This cap that sat right here spewed its grossness all over it. Came off like so. All right. So let's have a look at these transistors. I think I should have double checked this, but I'm pretty sure they all have the same marking. I think it says 1 AM and then Z on the line. So I know very little about transistor specs. Oh no, this is different. Yeah, I should have double checked that before I removed them. Yeah, why 1 AMZ? So there are two of the 1 AMZ and one of the. It's hard to read. Bring it a little closer. That's so hard to read. Yeah, I don't even know how to read that marking. So we can at least do a very quick sanity check. So because I think transistors like these are supposed to, they're very similar in function to diodes. In that they have a base in the middle and then a, what's it called again? Emitter and a collector. Yeah, thanks for checking. One AMZ was on the left, thanks. And I think we can also get that from looking at the bomb. Maybe they're near Q1, Q2, Q3. Q1. Q3 is the 2 and 3 904. 904. Yeah, so Q1 and Q3 are the same, and Q2 is the odd one out. Oh, sorry, I didn't show the spreadsheet I was looking at, but there it is. I just wonder what happens if I do a quick diode check on these. So if you put the positive, it's hard to do. They're so small. Okay, no reading there. The other way around. Still no reading. How about here? No reading. Weird. So I'm pretty sure I got something. I got some voltage drop earlier. Oh, here we go. So if the negative is on the base and the positive on the, what is that then? Collector? Is that a collector then? We're getting a diode-like voltage drop. Yeah, so negative on the base and positive on the collector, and then we get the typical 0.7 or 0.66 voltage drop. Same with this one. Should show what I'm looking at. This one has nothing happens. So the middle one here, so let me have a quick look at this on my loop. Yeah, this is the one that's a different type. So anyway, just goes to show that I know very little about how transistors are supposed to work. But we could confirm that both of these IMZ or 1AMZ have voltage drop from the base to the collector. So the rusty one that got a bit corroded then at least has some function. If we do that in the round, nope. No voltage drop. What's this one? Okay, the other one is opposites. So I'm getting the voltage drop when I'm on the positive on the base. So I don't know if that means that the collector is on the other side with this transistor, but we can clearly see that the behavior is different between these two types. So anyway, again, I don't know much about transistors beyond that they are diode-like. They just control current in one way or the other. But all three have some kind of function, so I will install them on the board. This is gonna be fiddly. Let's see. I don't want to use soldering paste anymore. I haven't had much luck with that. So let's see how we can do this without tearing our hair out. So what we have, let's see if we can move the camera a bit up. Let's turn on the soldering iron. Oh. So we want to install this one here. This one here, and then the last one down there. Let's clean up first. I think there's something wrong with this paste. The first batch of paste that I got from eBay worked perfectly for the first few projects. And then I didn't read the instructions well enough, so I just left it sitting in my drawer here, and afterwards I realized that it needs to be put in a fridge. It needs to be cooled below 10 degrees Celsius or something like that. So it went bad. It went stale after a couple of months. And the new one that I got from Mauser just a month ago or so, and I've kept it in the fridge. It was been bad from the beginning, or it's the exact same brand, exact same product, but I suppose maybe Mauser messed up with the refrigeration or something, because it's not good. Speaking of not good, I think these joints were not super clean. Yeah, I think it's just a problem with storage of that stuff. So let's see how painful it's. Oh, sorry. Clean. And then let's tin. One, two tinned little pads. Alright, let's jump to the side there. Ouch. Put this transistor right there. Solder. Okay, kind of stuck on there, that's good. And we do another, we push it down, well, holding out, or I'm pushing, so my technique is tin one pad, put the component on top, and then hold on to it on the sides first, then apply heat. That will get the component to stick on there for starters, and then, but it will probably poke up a little bit, it will not be flush against the board. And then I rest my tweezers on top, and then I apply some more heat, so that kind of pushes it down onto the board, so it was nice and flush. And I'm gonna get different tweezers because these are pretty messed up now. I have fresher tweezers I'm gonna use, angled and straight. Let's get the angled. So kind of messy. I think there was some bad solder on the tip there. I really need to change my little solder pads, or the little sponge. But I bought sponges a long time ago, but I can't find them. So I'm using a really old one that's dirty. Which is probably not good. That's better. Alright. Next transistor. Hold it steady. Apply heat. I think it's stuck. Rest the tweezers by heat. I think it's flush. Alright, it's not bad. It's messy, but it's not bad. See if we can remove the residue. I think we need some wick action there to get rid of solder residue. Alright, pretty happy with that. Let's double check we got them in the right order. Yeah, it's good. Let's do this one. On pad. Don't stick, don't stick. Okay, it's gonna be awkward. Let's twist it around. Oh crap. It slid off. Let's try that again. Jeez. I think that's alright. Reminds me, I should probably focus less on my face and more on, should give you this view again. Keep forgetting to do that. So you can see roughly where I'm working. It's funny, I didn't realize kind of how dirty these tweezers were until I saw it under magnification. Maybe I should try and wipe them off a little bit on the paper towel here. Maybe it's just burnt. Anyway. Looks okay, maybe a little bit too much solder here. Let's reflow this joint as well. Add a little solder there. I think that looks okay. Of course, there's lots of flux to clean up here. That thing is on there. Alright. Transistors are done. So, what's next? We should do the remaining salvaged parts, I think. Maybe not the crystal, because it's gonna be in the way when we do some more deep cleaning of all the flux. I think this thing here, it's just a weirdly shaped diode, as I understand it, and I think it goes on D3 over here. I think this is where it goes. And then these three fuses go in the F slots. Fuse 1, fuse 2, fuse 3. So one of the fuses sit next right over here, that's fuse 3. And then the last fuse is over the edge here, fuse 1. So let's get those on. Look at all that flux. Gross. I think this sheet does tell us what kind of fuses they are as well, which is always interesting. Let's check D3 first. D3 diode. It's a diode rectifier for this SCSI and swing chip. 1 amp, 550 volts. I don't think, I'm not sure, are diode rectifiers polarized? It seems to have a, polarity strip right there. Right? It's towards one end. But I'm not sure I'm seeing the polarity on the silk screen. That's not helpful. Let's see if the donor board has polarity. Oh, yeah, look at that. There you go, D3. That's a clear polarity marking. Why is there no polarity on this repro board? That's not helpful. I think we have 2SI board past this too. Look at that. Same one, this 2SI board. So according to the 2SI board, so if we take this as a source of truth, actually wait a minute. Yeah, no, never mind. I don't think we have. Silk screen underneath should talk about. Let's see here. I mean, it's likely that. Oh wait a minute. So one way we can tell again. So this is kind of a lazy way to do it, but if we look at fuse 3, so it's connected in serial with fuse 3, according from what I can tell. Let's check that with continuity there. Yeah, maybe you can't hear the beep, but yes. And as far as I can tell, it's the same on this one. The record board certainly is doing the same, yes. There is continuity in the same direction. So I think we can use that as indirect evidence to say that the polarity of this diode rectifier should be the same on the original board as on the record board. Now, what was the original orientation of that fuse? So, yeah, so this may not be the most scientific way to determine this, but I'm thinking just to save some time. In this case, it looks like the stripe is towards fuse 3. Let's check that on another a bit better. These are not great, but yeah, that's what it looks like. This is way too small. Yeah, the stripe is clearly towards fuse 3. Let's use that. So we should attach this as such. So I've never soldered a fuse diode rectifier before, so this will be interesting. Let's add a whole bunch of solder onto that pad. Oh, I should have cleaned it first, of course. Anyways, it's a good amount of solder. Okay. This is a lot of solder. I guess needed another second to. Oh, jeez, that's not it. Nice joints. Let's try again. That's good enough. Solder the other end. There we go. Our oddball diode is on. Now we can do some wiping down here. Oops. I'm gonna get rid of that red flux there. Okay, now it's clean. I think I need a new cotton bud Q-tip. So I'm pretty sure these fuses do not have polarity. Okay, let's check on the donor board just for fun. See if we see anything there. Doesn't look polarized. This is interesting. How do you solder these? It's kind of one side is obnoxiously, there's like an overhang. So generally, my philosophy when soldering parts like this is do the easy side first, so you have some stability for the hard side. Just gonna tin all of these. I'm gonna tin the other ones off camera just to get it done. Okay. Let's see if we can. Next to fuse needs to go over here. Fuse. Yeah, fuse 3. See how this goes. There we go. Okay. Oh, crap. So this one is not great for my usual technique because it's kind of top heavy. Oops. Oh my gosh. Did I ruin it? Did I ruin the portable fuse? Wow. I may have ruined that one. Look at that. So either these are always very fragile, or they were weakened. So let's see if I have. Yeah, I can always steal fuses off of my 2SI board. There's a fuse that on there. I don't know if these are repairable once they've kind of fallen apart like this. Probably not. So let's be more careful. This one is kind of dirty underside. little bit of scraping there. This yellow residue. Anyway, let's try this again and try not to ruin more of these fuses because they're very sensitive. So, not a great joint, but I can fix it later. And I'm just gonna do this off camera so I don't. Weird. I'm not sure I have enough clearance. So I'm gonna go to this screen for a while. I'm gonna not use the microscope because this is gonna be pretty fiddly. Be very careful when I hold on to this thing. Move it over to the side a bit so that I can hopefully So I'm not even sure how to fit these fuse on these pads. I don't think I have any exposed pads down here. Do I? So I don't know if that fuse is on there alright. So I assume these fuses have continuity when they are functioning. Yeah. Continuity. So do I have continuity between these two? So let's turn on the microscope again. So I have what seems to be this may be on there now, but it's so hard to see because of this overhang here. So let's see if there is continuity between these two VS. Oh yeah, there is, okay. So that fuse is on there. I should have tested before I attached it, I guess, but too late. Okay, for this fuse, there's no continuity right now. And once we attach this fuse, we will hopefully get some. Right, so what we learned is it needs to be attached as close to the edge of that pad as possible, like so, and then we basically have a little bit of leeway underneath that overhang on the other side. I'm gonna do this off microscope again, it's just too fiddly. Okay. Let's see if we have a good joint there. Let's test the continuity between this via. Nope. So we have continuity here, but not at the VS, which means that the joint is not good. That's annoying. So I just got solder on the fuse itself and not on the pad, obviously. Let's try again. Oh my gosh. Did that break the fuse? Jeez. There's continuity now, but that whole plate under there shifted. What is fuse 2? What does that control? What is fuse 2? It's for the external floppy. I guess it's not mandatory. But that does not look good. These are frustrating parts. And fuse 1, what is that? It's a fuse. It doesn't say what the fuse is for. It sits down by ADB. So it could be the ADB fuse, which is probably important. We should probably install that one. We should probably remove fuse 2 because I think I broke that. Degrees. Let's heat up this fuse, see if it comes off as a whole or in parts. Yeah, it's in parts. Sorry, I did it off camera. So yeah, to demonstrate, the moment I desolder this fuse, this is what happened. Bam. F1 is always scuzzy. Okay. That could make sense too. Yep. Although, let's see, what did it say over there? Because I think fuse 2 and 3 had more documentation. F2. Fuse 3 is for SCSI. So if you look at the doc here, it says fuse 3 is for SCSI. So it's the one we have. Oh, is that you said? No. Okay. So we have two very broken fuses. Let's see if we can salvage fuses from the faulty 2SI board. So we have 3 fuses that I can see. Let's start, let's see, over here. Here. So let's get these off. Use some flux. I don't know if this actually helps or not, but maybe it's bad. very gently. Okay. One fuse off. Let's see if it's equally easy to remove without the flux. Yep, you don't need the flux for that. Right. Thank you to a sideboard. You're being very helpful. So maybe when soldering these fuses, I need to use lower temperature. If they break so easily, let's bring the soldering iron down to 340. So the external floppy fuse may be optional for us right now. I don't know if it will stop something from working, but I don't feel a huge rush to have external floppy functionality on this board. Let's clean that up. So I'm gonna do this off the microscope again. Turn on my LED light a bit. I wonder if there's a trick to this that I don't know. These fuses are really frustrating to solder. So I tried sort of slide it from the side while melting the solder, but that just caused the solder on the pad to kind of transfer onto the fuse. Okay, so it's on there. Now I need very carefully. I shouldn't push it. I can't push it at all. I need to apply solder right here. Oh my gosh, this is so bad. No, that immediately just fell apart. Just immediately fell apart. Huh. That's not good. Yep. That is very frustrating. Yeah, I don't know what to do with this. Let's try this one fuse down over here. So maybe these fuses is where it's kind of mandatory to use solder paste. I don't know. I don't know. Something special about soldering fuses that could increase in conductive metal. I don't know. I've never dealt with fuses that look like this before. Oh, uh-oh. Move around. Okay. Let's test continuity. Okay, we have continuity, so it seems this fuse lives for now. I mean, it's a fuse, right? To make sure that when a short happens, the circuit gets disconnected. And there's these fuses seem to be constructed using two plates, two little conductive plates. That are held together but will fall apart very easily. So we have one final fuse we can steal. I just get obsessive at these things. I want to try to see if we can salvage F2 and get it onto the board. Self-healing. Yeah, that's, I agree. I've seen self-healing fuses in like little packages before, like little, they look like tantalum caps almost. Here. They conduct heat so easily. It's like they they just suck up the heat. Okay. Let's see what we can do here. So I think it was a little bit more helpful. Let's keep this a little bit up. Right. A bit more solder there. Pretty good. And I think it was helpful to solder the yeah, the thicker part first. Oh crap. I should not be throwing this thing around. Very carefully. Very, very carefully. Oh. I say while dropping it around. Throwing it all over the place. Okay, we have continuity. So that fuse is on there. Wasn't destroyed. I guess that's a Success. But that took, look at these. Look at these poor little guys. Such carnage. Such carnage. Somebody watching knows if these are actually repairable. Can you put them back together? I doubt it. Yeah, it's not good. I think they just suck up heat so quickly, and then they deteriorate if you kind of touch them, if you push them too hard while very hot. So you have to be very quick about soldering these guys. I just wish the pads were a little bit further apart. Then it would be easier to solder them. But at least they're on there now. Alright. Well, I think I want to solder all the caps. So I got some. Let's see here. Okay. So I have some aluminum organic polymer caps here. 16 volts, 47 microfarads. Okay. And then I have these, or maybe one or two of these 50 volt 1 microfarad, which I think there are just a few of. And this has some extra precautionary measures, because this is a moisture sensitive device, level 3. The bag was sealed on December 20th, which is a month ago, and it will need to be mounted within 168 hours of opening, after the bag is opened. So once I open this, I need to assemble. Actually, before we do that, let me have a look. Where is the 50 volt 1 microfarad? This one, C. So we have one at C6, which is right here, and C6. And that's it. I think it's just that one, if I'm not mistaken. The one right here. I ordered two, which is usually a sign that I need one. Open this bag. In the bag. We have another bag. And we have this little moisture measurement. Do not use this card into a bag if it's 60% pink. So I have to bake parts if 60% is not blue. This was a level 3 part, right? I think it's said somewhere. So I think all of these are blue. So this is the card I was looking at. So it seems like the moisture level has been fine inside that bag. See there? That's a small cap for a big pad. So this is one of these square packages. So it means that the stripe means positive, I'm pretty sure. Let's clean this up a little bit. Let's double check. It's C6 that we want, right? Yeah, C6. Yeah, it's good enough. Actually, no, I want to angle it a little bit better. Yeah, that's good enough. Alright, that is on there. And I do believe that all the other caps on this board is going to be the 47 microfarad kind. So these are organic polymer. Just trying something different from the usual electrolytic SMD or the tantalums. Let's have a quick look at the bomb. So yeah, C11 is different. Oh yeah, these are the big ones, right? Yeah, C11 is an axial. So is C2. But yeah, but basically C1. So let's go down the list just to be careful. C1 is definitely 47 microfarad variant. Let's get this soldered. These barrel type caps, the stripe is the negative, if I'm not mistaken. Seems alright. Definitely a mess there. There's some grossness on this. It's iron. Let's clean that up. So we have C7 right over here. C7. C7 is our 74 microfarad. Oh, sorry, 47. Ah. Awkward angle. Let's move on to these C3, C4, C5. On the bomb, we can confirm C3, C4, C5 are all 47 microfarads. Stripe is negative. So let's I'm not should yeah, I've not been really following my on the device well with these caps. They're not super flush with the board. I guess I'm getting tired. Yeah. Don't look super great. I could rework them later if I feel like it's... Sorry. Yeah. Keep forgetting this step, right? Push it down to get the nice flush against the board. When you start taking shortcuts, that's a good sign that you need to take a break. But I'll just finish these guys. It's kind of fun to install caps onto a fresh board rather than recap a dirty board. Nice change of pace. So now we have C8, C9, C10. C8, C9, C10. Oops. Oh, it's in the wrong one, but we can work on that. We can work with that. Let's set a king. Do these guys here. Here. Plus. Oh, crap. Yep, losing focus, losing focus. Okay, they're on there. Seems alright. Oops. And we have C13 down here. C13. I'm pretty sure C13 is also usually 47 microfarads. I'm just gonna, I think I'll just finish off these caps off of the microscope. It's just the same thing over again a couple of times. We have C12 down here. We should double check, I'm pretty sure, but yeah, C12, 47 microfarads. Looks good. Should probably press down, yeah, nice and flush. It's on there. Alright, let's see what caps we have left to do, if any. Surface mount caps, that is. I'm not sure. So I have 2 more left here. I may have ordered 2 extra, but that may be it, unless I'm tired and can't really see straight right now, which might make sense. So I do want to be able to say that I finished the surface mount components. So I think what I want to do is to wrap this up with 2 diodes. So let's switch over to microscope. So 2 diodes down here by the battery. I think they control the battery voltage going to the PRAM, etc. And those were very, very battery bond. So I have fresh new diodes sitting around here somewhere. Diodes. Okay. Probably these. It says 40 volts, 40 volt NPN SS transistor. Oh, sorry. Why does it say trans? I don't know. 60 volts diodes, bipolar. Let's see. I don't think these are the ratings on these are super important. But let's have a quick look at D1, D2 on the bomb. D1. Oh, okay. So this BOM recommends 1N9144148. Which I think is what I ordered. Oh, yeah, right. Yeah, so these are MMBD914. What I have here is MMBT3904. Rated at 100 volts, peak reverse voltage. Did I order some other? Oh, here's more diodes. Oh, 100 volts. So this is more like it. Oh yeah, right. These are transistors, of course. Okay, they're made by diodes. I'm getting tired. That's why. So I may have actually ordered replacement transistors, and I forgot about it. Anyway, good to have in case. This is what we need: 100 volts diodes. Looks about right. Two of these. So I understand these are actually perfectly optional. You only need these diodes if you're installing a PRAM battery. But I intend to do that, so let's see if I can peel this off. There we go. Alright, so two of these. Here they are. Two little diodes. Very cute. Here we are. So let's use the same technique again, which is to put some solder on the base pad. Oops. It's not. I need to turn down this light again. I'm not getting very much heat on that. Okay, that's tinned. That's tinned. Okay, this is gonna be fiddly. Not bad, but I want a little bit further to the side, just so it looks a little bit better. So, here. I like how that looks. Is that a good joint? Weird. So that third pin there, it's just not attaching to the pad. So I probably need some flux in there. Maybe I need to bring the temperature up to 55? It's off camera. That's better. It's on there now. Okay. Solder on the very last. I think this is going to be the last surface mount component for this build, if I'm not mistaken. Get a good shot. That's an ugly looking solder blob on there, but clean that up later. And that's good. Okay. Press down and get it flush. Yes. Nice. And then finally, let's solder these two little bits. Let's see if we can get good joints this time. Oh yeah, that looks good actually. Beautiful. We can redo this one like so. And then probably just a tiny bit of touch up. There's so much. I'm sorry, this solder tip, iron tip is just getting really dirty. That looks alright. And there you have it. What did I? Yeah, I kind of took away a little bit of the base joint there. Should probably make it nicer. There you go. Nice and round joint. Alright. So there we have it. Let's angle this camera. Hello again. So I think too much glare. Yeah. Focus. What we have here is a board with all the surface mount components attached. That was quite a journey. But I think this is the hard part is done. What's left to do is to solder on all the IC sockets, SIM sockets, to solder on the power header, or the interconnection header here. We also will need 2 large axial caps, one here, one here. And after that, I think we should be ready for the chime test to see if this computer boots, if it's spring back to life. And yeah, that's it for today's episode. Thank you very much for watching. Have a great rest of your day, evening, and bye-bye.